Try to get going. Some people seem to want this to be the last class.
What do you think about
Study
study guide?
guide. Okay, so today we want to continue our look at risk and return. In some ways, the most elemental, fundamental notion in finance, investment. People invest to earn returns. But with investment, there's a risk. So the objective really point here, which was sort of one of the big issues in finance, how do we put some numbers on these things? How do we measure return? How do we measure risk? So we started last week's class with this PowerPoint here. So realized and expected rates of return and risk. So we started with the realized return. That's a look back. This has actually happened, okay? So it's basically some arithmetic on how you calculate the realized or the actual return on an investment. And I hope and trust as diligent students, persons, look back at that. And we went through a couple of examples. Is that your job? Okay, so Now, unfortunately, when you undertake an investment, you are doing that on the basis of an expectation. Okay, so expected return is what the investor expects to earn from an investment in the future. And I guess I often say to students, in a way, that in a way is a big difference between, say, accounting and finance. And a lot of people are doing degrees in accounting and finance, and on the surface it looks, some parts look similar. But accounting, usually when you're doing accounting, the thing has already happened. And you have a set of rules as to how you record them. Finance, by definition, in other ways, is forward-looking. Okay, you're making decisions where you will really only know the outcome in the future. And one of the unfortunate realities of being human is we can't know the future. The future is not knowable. So then there's a degree of uncertainty, a degree of judgment built into finance that maybe it's not the same degree in accounting, which makes the discipline a lot closer to economics. So how might we theorize about it? So how might we try to measure it? You make an investment, what rate of return do you expect to earn? How might we put a number on that? And essentially, early finance theorists, or what you may call traditional finance theory, fell back on basic statistics. The basic notion in statistics is your simplest forecasting model is to use the average. So if you're going, so if you went up on a blind date, and you're going out to dinner with a St. Lucian male, that's all you know about the person. They're St. Lucian and they are male. What height would you expect that person to be? So basic statistical theory says, what is your starting point? What is your simplest model? What information would you look up to develop an expectation of the height of that person? The idea is that your basic focus, what is the average height of a St. Lucian male? So basically your simplest statistical model is that you forecast based on the average. Now what height the gentleman turns out to be, he could be that height, he could be taller, he could be shorter, which is exactly how we think about risk. So it's going to be important to understand what we mean by risk in this framework. So traditional finance theory says the expected return from an investment can be modeled as the weighted average of the possible returns, where these weights are determined by the probability that an outcome occurs. So what is your expected grade on this course? How might you formulate that? You say, well, there are a number of different possible grades. You assign a probability to each, and you get the weighted average. So we can think of it as like that, the expected rate of return on an investment here. Rate of return 1, that's one possible rate of return, multiplied by the probability of that rate of return being earned, plus second possibility, rate of return 2 times the probability. So let's look at that in a slightly different way. So you've invested some money in shares of ECAP. What is, so today is April 1, All Fools Day. And you say, well, I want to invest this money and hold it for 1 year. What is my expected return? So if we just follow the logic without worrying too much about where the numbers come from. He said, okay, my return depends on the state of the economy over the next 12 months. The rate of return depends on the state of the economy. And I determined that there are three possible states of the economy. The economy could go into recession. It could have moderate growth, or it could have strong growth. So these are the three possible outcomes, I may call states of nature. I know stats was Econ 1005, I think, was a long time ago. But somebody should have told you something about this. And then you want to assign a probability. What is your judgment? So in this example, you think there's a 20% chance of a recession, a 30% chance of moderate growth, and a 50% chance of strong growth. So the probabilities or the weights must add up to 1 or 100%. Okay, so the weights, the probabilities must add up to 100%. Then we have the end of year selling price of the stock. What would the shares in the company be worth at the end of the year in the three scenarios? And maybe we can go to column D first. So you paid 10,000. So 10,000 is the amount you invested. So you bought one stock for $10,000. So that's the amount you invested. Everybody with me so far? So at the end of the year, March 31st next year, 2026, if the economy goes into recession, then you expect the price of ACB shares to fall to 9,000. Okay? If the economy goes into recession, the shares will be worth 9,000 each. If the economy experiences moderate growth, the shares will be worth 11,200. And if the economy experiences strong growth, then the shares will be worth 12,200. Everybody still with me?
Yeah.
So from the equation, we looked simple arithmetic last week. What is the cash return from your investment? What is your return in cash under the three scenarios? If the economy goes, so you pay 10,000, that's the amount you invested, right? If the economy goes into recession, the value falls from 10,000 to 9,000, so you have a loss of 1,000. That's your return in cash, negative 1,000. What's your return in percentage terms? It's your cash return, E divided by D. Your cash return divided by what you invested, so you would have a loss of 10%. So if the economy goes into recession, you expect to lose $1,000 because you invested 10,000. It's now worth 9,000, so you are down $1,000. That's your cash return. And in percentage terms, that's negative 10%. Everybody following that?
Yeah.
What if the economy experiences moderate growth? Then your 10,000 investment grows to become what? It's now worth 11,200. That's the end of year value. So you have a gain of $1,200. The cash return is positive 1,200. And in percentage terms, 1,200 divided by 10,000, you have a positive 12% return. Everybody following?
Yes.
And if you have strong growth, you bought the stock for 10,000, but if it's strong growth, end of the year you were at 12,200. So your cash return is $2,200. C minus D. $2,200 return in cash. And in percentage terms, E divided by D, 2,200 your cash return divided by your initial, so you have a 22% return. So in effect, when you go into this investment, you say, okay, I have to, how much do you have to put in? What's your investment?
10,000.
10,000, right? So beginning price of the stock is 10,000. What will my return on this investment of 10,000 be in 1 year? What is my expected return? I don't know what it's going to be. I'm not God or goddess. So I said, okay, my return will depend on what happens to the economy in the next 12 months. And I said, okay, there are 3 possible ways the economy could go. I've made that decision. It could go into recession, and I think there's a 20% chance of that. It could experience moderate growth, and I think there's a 30% chance of that. And it could experience strong growth, and I think there's a 50% chance of that. If it goes into recession, then the asset that was worth 10,000, I expect it to now be worth 9,000. If we have moderate growth, the asset that was worth $10,000, I now expect it to be worth 11,200. And if there's strong growth, the asset that was worth 10,000 is now will be, I expect it to be worth 12,200. So what is my return in cash? There's a recession, I expect to lose $1,000. There's moderate growth, I expect to make 1,200. If there's strong growth, I expect to earn 2,200. And if I put those in percentage terms, recession, I expect to lose 10%, minus 1,000 or 10,000. Moderate growth, I expect a positive 12%. 1,200 divided by 10,000. And strong growth, 22% return, 2,210, right? So to get to my expected return, as we said with the formula, is the weighted average of the possible return. Right? So we can take this now to mean that I think there's a 20% chance that I would lose 10% on my investment. Everybody saying that?
20%.
There's a 30% chance that I would make 12%,
Yeah, okay.
and a 50% chance that I would make 11%. So I just do the arithmetic now of the weighted average. B times F. 20%, 0.2 times 0.1 gives me minus 2%. 20% times minus 10% gives me negative 2%. 30% times 12%, 12 by 3 is 36. So 3.6%. 0.5 times 22 is 11. So I add up the weighted average, the sum. So my expected return under these assumptions is 12.6%. Everybody following that? So column B, the probability of the state of the economy, which is column B, multiplied by column F, which is my return that I expect in each particular state of the economy. And I find the product, B times F. 20% times minus 10% is minus 2%. 30% times 12% is 3.6. And 50% times 22% is 11 when I add. So my expected return on this investment is 12.6. Okay. And we can just do that through the equation. Come back to 12.6. So now we want to think about risk. So how do we think about risk? So traditional finance theory, we define risk not necessarily in a common sense way. When you think so, and there's no right answer. When you think about risk, how would you define the risk of an investment? Just your common sense, natural reaction. What is the risk of an investment? How would you define it? Right. Okay, so you might think, and that's a normal, we think of risk as the chance that I would lose money. You know, what is the likelihood that I would lose money? So if I'm comparing two investments, which one would I think is riskier? The one that has a greater chance of losing money.
Right.
But that's not how risk is defined in traditional finance theory. Okay? That's important to keep in mind. This is why we might need one more class.
Okay. Okay.
Because I need to contrast that to behavioral finance. So, traditional finance theory, following traditional statistical theory, it defines risk as uncertainty. What is the chance that my realized return will differ from my expected return? Okay, so traditional finance theory defines risk as uncertainty. Not so much the chance of making a loss. Okay, you define risk as what is the likelihood that my realized return, which is the first thing we did on the slide, will differ from my expected. So I go into the investment on the basis of an expected return. In 1 year's time, we don't know what the hell will happen, right? In 1 year's time, I will know what this actual price is. And that will determine my actual return. So what is the chance that my actual return will differ? My actual or realized return will differ from my expected. And that's a nice, convenient assumption because we have a statistic that measures that. Okay? The variance or the standard deviation. So in traditional finance theory then, risk is quantified, is measured as the variance or the standard deviation of returns. And at the time, this was a very important breakthrough in a way, because we could now put a number on risk. We didn't need to talk about risk in a general way. We could actually put a number on it. So the variance, the average squared differences between the return and the expected, and the standard deviation is just the square root of the variance, and that's what we know commonly. So let's see if we can put some numbers on that. So assume that you have two possible investment alternatives. Okay, so one is a U.S. government treasury bill. And prior to Donald Trump's presidency, we think that the U.S. treasury bill is risk-free. There's no risk of default. They promise you 5% and you're going to get your money back. Or you invest in the shares of ACE Publishing. Okay, so let's look here at ACE. So you invest your money in ACE Publishing. What is your expected return and risk? So you do an analysis similar to the former table, and you come up with this, right? You think you estimate, good morning, that there's a 10% chance of losing 10%. I guess you're forgiven for being late. You're probably the only member of the class who showed up for the 5K. So we'll forgive you. So there's a 10% chance of losing 10%. a 20% chance of earning 5%, a 40% chance of earning 15%, a 20% chance of 25%, and a 10% chance of 40%. So there are 5 possible outcomes, okay? Again, importantly, you see that these probabilities or these weights add up to 1, okay? So 10 plus 20 is how much? 30? Plus 40 makes it 70, 90, 100, so the weights add up to 1. So what's the expected return on this investment? Okay, so what's the expected return? So there are 5 possible outcomes. Lose 10%, make 5%, make 15, make 25, make 40, and these are the probabilities. So what's the expected return? Minus 10% times, there's a 10% chance of losing 10%, so you multiply it and you get negative 0.01. Everybody following that? No? A 5% chance, sorry, a 20% chance of making 5%. So 0.05 times 0.2 gives you 0.01. A 40% chance of making 15%. So you multiply, you get 0.06. A 20% chance of making 25%. Multiply that, you get 0.05, and 10% chance of making 40%. So your expected return is 15%. That's the weighted average of the possible returns. Everybody's good with that, or that's confusing?
So it's a sum then, basically?
Well, you multiply. So again, it's the same calculation we did here.
Okay. Also,
How did we get the expected return here of 12.6? 20% chance of losing 10. So 20 times minus 10 gives you minus 2. 30% chance of making 12. 30 by 12, 3.6. 50% chance of making 22, 50% times 22 is 11, so when you add that up, 12.6. So you can do the same thing here. 10% chance of losing 10%, you're doing that multiplication. 20% chance, so that's what is set up here. Okay, 10% chance of losing that, 20%, and we get to an expected return of 15%. Okay?
okay.
Now, what is the risk of this investment? How can we put a number on it? So this is where now we are getting to step 2. B, column B, minus the expected return, and that number is squared. So in state of the world 1, what rate of return do you expect to earn? If state of the world 1 occurs, what do you expect to earn?
Negative 10%.
You expect to lose 10%,
10%.
right?
Lose 10%.
What is the expected return overall when you take into account the 5 states? When you take into account all of the 5 states and find the weighted average, what is your expected return?
0.1%.
15%, right? So in here, all you're doing is you're taking the expected rate of return in state 1, which is column B, and you're subtracting it from your expected return, 15%, and you're squaring it. So 0.1 minus 0.1 minus 0.15. When you square it, then you get 0.0625. 0.05 minus 0.15. So basically everything in column B is being subtracted from the average 0.15 to get these numbers. So 0.05 minus 0.15, when you square it, 0.15 minus 0.15 is 0, and you square it, still 0, 0.25 minus, you square it, 0.4 minus, and you square it. So that gives you column P. And then step 3, which is column F, is column E minus C. So now you're multiplying this column that you just generated by the probability. So 0.1, there's a 10% chance of state 1 occurring, times 0.0625, 0.2 times 0.1, 0.4, 0.2. Have all of that, so when you take the average of that now, you have the variance. You sum that, you get the variance, and you take the square root of that, that gives you your standard deviation. So we're saying now we can really compare these two things. Now I'm not going to ask you to work out standard deviation under exam conditions. We did that in stats, I suppose. So I won't worry about that. I'm assuming you know how to do this, because if you are here, you must have passed stats. So how can we compare these two investments? Which one offers you the higher expected return? The common stock, because the expected return if you work out is 15%. Right? Which one is riskier?
Common stock.
And how can we quantify that? What number are we looking at? The standard deviation is bigger, right? So, again, this was seen as a fairly important breakthrough that we could now put a number on things. Which one do you prefer? Which one is better? Let me know, which one do you prefer? Which one is better? The T-bill or the common stock?
Treasury.
Good question. Right? So which one do you prefer? And he's right, so we can't say one is better than the other. In terms of expected return, which one is superior? Common stock. In terms of risk, which one is superior? So which one you prefer depends on your stock or your preferences. So, now, without thinking about it to some extent, we are really a society of averages. You are bombarded with the average all the time. Okay, so let's take a fairly simple example just to try to hopefully reinforce this. So you have to forgive me for my age, but I'm going to use a cricket example.
Okay.
So you have these two batsmen, right? Batsman A and batsman B. And these are their scores over the last 5 years, right? So what's the average score for batsman A? What's his average score?
60.
His average score is 60, right? His average is 60. 300 divided by 5, right? And what is batsman B's average? What is the average score for batsman B? Also 60, right? So if you are watching a cricket game and these two guys come out to bat, what are they going to put up on your screen as they come out to bat? What information are they going to give you?
The highest score, maybe? And the average?
Right, so they come out to bat, what's going to come up on your screen? They're going to say, well, this is this guy's average and the other guy's average, right? What is that supposed to do for you? What are you supposed to take from that? These two guys walk out to open the innings together. And if on the screen it says batsman A has an average of 60, batsman B has an average of 60. What is that supposed to do for you? What information are you supposed to do with that information? How?
Much one's expecting to make.
Right, so then it's a way, okay, how do I expect this guy to perform? What runs can how many runs can I expect him to score? So in a way, it's information that you are forming an expected return. That you're forming an expectation of how much runs can I expect this guy to score. So all you're gonna put on your screen is the average. So what conclusion would you draw from this about these two batsmen?
That they
perform about the same, right?
Yes.
You know, these are two guys with an average of 60, they perform about the same. But you have this raw data, but when you look at this raw data, what do you see?
One is consistent performing and one is like a one-off thing.
So while they both have the same average, the likelihood that they're going to score 60. So if this becomes your expected return, right? Mm-hmm. And we said earlier, the risk, how do we define risk? Risk is the chance that the actual will differ from your expected. Which of these batsmen is riskier from that viewpoint?
Batsman A?
Batsman A, because in any one innings, based on the history, the likelihood that his or her actual score will differ from your expected is much higher. So we try to do that variance thing, and that's what we try to do. So we think of the variance of A, the variance of B. So this is what basically they take. So you take the actual minus the average, and you get a number, and you square it. So again, you take the actual, you subtract it from the average, and you square it. You know, each and every occurrence, you subtract it from the average, and you square it. Actual minus the average. Again, why do you square it? If we don't square it, it's just going to add up to 0. So it's just a mathematical convenience.
Okay.
Okay. What about if, so we can see here, you know, if we take the average of that average variation for this guy, we get a number, a big number. We do the same calculation for batsman B. 60 minus 60 squared 0. So it's going to be 0 throughout, right? Give me my number. So The average of 0 is 0. And then we can just find the standard deviation. So the standard deviation of A, standard deviation of B. We take the variance and we find the square root. Okay, so square root can be found, you can just raise it to the power 0.5 if you want to do that. So now when these two guys come out to bat, what if they give you both their average and their standard deviation? What does it tell you about the two of them? Now you have more information. Batsman B is the riskier batsman. In terms of his score from game to game, there's more variation around the average. So even though they have the same average, there's a greater chance that batsman B's score will actually be what you expect it to be, whereas there is more variation around that average. Okay, so that really is supposed to be the big benefit of this traditional finance theory. We can now put a number on risk. It's not something we just talk about. That ACB is riskier than ECAB as an investment. We can take the numbers, work out the variance, standard deviation, and see what that is. Okay. Again, I'm not so interested in your ability to do arithmetic. Sorry?
I said no calculation exam then.
No, I didn't say that. Okay, so what do I want to do? Okay, so let's just do that. So using the data below, what is the standard deviation or the risk of the Standard & Poor's 500 average for the years 2005, 2009? So you have the actual returns in each of those 5 years. So 2005, investors earned a 4.9% return. 2006, 15.8. 2007, 5.5. 2008, people lost their shirts, negative 37%.
Okay.
In 2009, a rebound 26.5. So can we put a number on the volatility? So we can compute the average. So the average during this period was 3.1% a year. So if we take 4.9, if we add all of these and divide it by 5, you get an average of 3.1%. So the expected return, we would say, is 3.1. That's the average. So what is the formula? How do we get the variance? So again, we're going to take each return in each year, subtract it from the average and square it, and divide it by n minus 1, t minus 1. Again, that's not so important for our purposes.
Okay.
So you get a variance of 5.8%. So, let me see, do I have this on the table? Yes. So in 2005, what was the return? 0.049. The average 3.1. So that's the difference, and we square the difference. 2006, the actual return was 15.8. We subtract it from the average is 3.1 with 12.7, and we square it. So when we add all of these, the sum is 2.33%. We add all of these squared differences. We have 5 years, we divide by n minus 1. Hopefully that jogs something in the brain from Econ 1005. Divide degrees of freedom, n minus 1. So we divide by 4. So the variance is 5.8%. And then we find the standard deviation of that, which is 24.1. So let's talk about this. Maybe we can ignore that. Do I want to ignore that one? Okay. So that's well and fine, but where we really want to go, now in reality, people don't really invest in just one asset. They invest in a portfolio. So we are really interested in being able to calculate the risk and return of a portfolio where you invest in more than one asset. And really the very important critical concept of diversification. So this PowerPoint slide is extremely important. You want to pay loads of attention to it and the associated problems. So in some ways, the most important concept in traditional finance is the notion of diversification. So we all think intuitively that there's a trade-off between risk and return. If you want more return, other things being equal, what would you have to do, or what would you expect to do? If you want to earn more returns, you're prepared to take more risks, right? Saying the same thing from another angle, if you want to lower your risk, what should you be prepared to accept? Lower return, right? If you want to lower your risk, then you should be prepared to accept lower rates of return. So there is that trade-off. Now, diversification, or portfolio diversification, is really seen as a free lunch, in that with appropriate diversification, you have the chance to lower your risk without lowering your expected rate of return. So that's a pretty. So you expected, so at the end of this, what should you know how to do? Hopefully some of this is a review of some stuff you did in FM1 as well. What is the, should we calculate the expected rate of return on a portfolio of assets? You should also be able to compute the risk or the standard deviation of a portfolio of assets. And really understand, explain the concept of diversification. Okay, so what's the expected return of a portfolio? So again, this should be what is a now familiar calculation of a weighted average. Okay, so the expected return of a portfolio is the weighted average of the expected returns on the assets in the portfolio. Okay, so let's see an example. So you have a portfolio where you have 200 shares of Apple worth $200 each, and you have 100 shares of Coca-Cola at $60 each. I think I have a typo somewhere in there. So you have, so your total portfolio is how much? 100,000, right? That's the total amount of money you have invested. You have 100,000 invested. 200 by 200 is how much? 200 shares at $200 each, that's about 40,000. So Apple is 40% of your portfolio. Apple carries a weight in your portfolio of 40%. Okay, the percentage of your portfolio is accounted for by Apple. Therefore, 60% of your money would be in Coke. Okay, 1,000 shares times 60, 100,000. There should really be 1,000 shares, sorry. There should be 1,000 up there. 1,000 by 60, 60,000 divided. So the weights must add up to 1. So you have $100,000 invested. How is that $100,000 split? You have 200 shares of Apple that cost $200 each. So 200 by 200 will give you 40,000 divided by 100,000. So Apple constitutes 40% of your portfolio. And Coca-Cola is the other 60. It should be 1,000 shares at $60 each. So 60,000, 60%. So the weights again add up to 1. So what is the return or expected return on that portfolio? The percentage of your money in asset 1 times the return on asset 1, percentage of money in Apple times the return on Apple, plus percentage of money in asset 2 times the return on asset 2, percentage of money in Coke times the return on Coke. And if you have more than 2, keep going. Okay, so the problem, example. Suppose you invest 100,000 and buy 200 shares of Apple at $200 per share. So that's an investment of $40,000. And 1,000 shares of Coca-Cola at $60 per share, 60,000. If Apple stock goes up to $240 per share, and Coca-Cola stock falls to $57 per share, and neither of them paid a dividend, what is the new value of your portfolio, and what rate of return did the portfolio earn? Okay, so your portfolio, 200 shares of Apple. Apple went from 200 up to 240, so you have a $40 capital gain per share on your investment. Each share you have in Apple is now worth $40 per share more than when you invested. So that's what we call it, a capital gain, and distinct from the dividend. We talked about that last week. Whereas with your Coca-Cola shares, their value fell from 60 per share to 57, so you have a capital loss of $3 per share. So let's see. The new value of your Apple stock is 200 shares times 240. So that's 48,000. Your investment in Apple is now worth 48,000. How much did you start with in Apple? You started with 40,000 in Apple, but that 40,000 investment is now worth 80,000. And what about your Coca-Cola investment? You started with how much? 60,000? 1,000 shares at 60. You still have a 1,000 shares, but now each share is worth 7. So it's worth 57. So the new value of your portfolio is 105,000. The 100,000 you started with is now worth 105. Everybody seeing that?
Yes.
So that's a cash return of $5,000 because you started with 1,000. And if we put it in percentage terms, you've made a 5% return on your money. You started with 100,000. Your portfolio is now worth 105,000. So it's a 5% return. What was the return on Apple? Apple, you made a 20% return. You invested $200 per share, and each share went up by how much? By $40?
Yes.
So 40 on 200 is a 20% return. And in the case of Coca-Cola, you invested 60 a share, each went down by $3, so you lost 5%. So what's the return on your portfolio? You can get the same 5% using the formula. So the initial weights in your portfolio were 40% for Apple and 60% for Coke. We saw that earlier. So what is the return on your portfolio? Percentage of money in Apple times the return on Apple plus the percentage of the money in Coke times the return on Coke. What percentage of the portfolio was in Apple, we said? 40%. And what was the return on Apple shares? We said the return on Apple was 20%?
20%.
So 0.4 times 0.2 plus. What percentage of the return of the portfolio was in Coke? 60. And the return on Coke shares was negative 5%. So when you find that sum, it's the same 5% as we saw earlier, where the value moved from 100,000 to 105. So really, the 3,000 loss on your investment in Coke was offset by the 8,000 gain in Apple to give you a total gain of $5,000 or 5%. And again, you get the same result. Okay, so let me give you a few minutes to grapple with this one, see what you get. And I'm just sleeping off in class. I'll give you some work. Don't just come in, look pretty and drink water. Suppose you invest 158,000 and you buy 2,000 shares of Microsoft at $25 per share for an investment of 50,000 in Microsoft, and 3,000 shares of Pepsi at $36 per share for an investment of 108. So that gives you 158. If Microsoft stock goes up to $33 per share, and Pepsi falls to 32 per share, and neither of them paid a dividend. So what is the new value of your portfolio? What is the return on your portfolio? And can you get that same number back using the dates?
Microsoft.